Hi all, this video will cover a problem related to solution of differential equations using Laplace transform. In this video we are going to see the total response of a system described by a differential equation with some initial condition and an input x of t. First problem in this topic, the objective is you have to find the total response of the given differential equation. The given differential equation is d square y of t divided by dt square plus dy of t divided by dt plus 4y of t equal to dx of t divided by dt, and the initial conditions are also given. The initial conditions are y of 0 minus equal to 0, y dash of 0 minus equal to 1, and the input given is x of t equal to e power minus 2t u of t. So in the process of finding the total response, we have to calculate the natural response as well as the forced response. So the other name for the natural response is zero input response, the response of the system without any input. That's why we are calling this as zero input response. And the forced response is also called as zero state response, considering the initial state conditions are equal to 0. So in this problem, first we will deduce a equation considering all the inputs are 0, and we are finding the value of y of t, or we will solve for y of t. That is nothing but your natural response. Then we will consider the initial conditions are 0, and again we will solve for y of t with the mentioned x of t. Then that is nothing but forced response. Let us see one by one. The natural response or zero input response is calculated by equating the input equal to 0. In given differential equation, if any input term is available, then we have to make that input term is equal to 0. So here we are having dx of t divided by dt term, so we are making x of t equal to 0, and obviously the value of dx of t divided by dt will also be 0. In this case, we will consider the y of t as yn of t, since we are having natural response. So here we are considering yn of t instead of y of t. So the differential equation becomes d square yn of t divided by dt square plus 5 dyn of t divided by dt. This is m plus 4y of t equal to 0, since dx of t divided by dt equal to 0. So this equation we have to find yn of t. So to solve yn of t, we are applying Laplace transform. So applying Laplace transform, the equation becomes s square yn of s minus s into y of 0 minus y dash of 0 plus 5 into s yn of s minus y of 0 plus 4 into yn of s equal to 0. As we know, the initial condition y of 0 minus equal to 0 and y dash of 0 minus equal to 1 So sometimes we will call this y of 0 as y of 0 minus, interchangeably used. So just replacing the value of this initial conditions, and we are reducing the equation into another form. So this will be s square y n of s minus, here this term will get cancelled, or else you just put 0 for y of 0 or y dash of 0. Similarly, y dash of 0 equal to 1 and plus 5 s into y n of s y n of s minus y of 0 equal to 0 plus 4 into y n of s equal to 0. So here solving this needs, we need to take the y n of s common. In this case, y n of s taking common will result s square plus 5s plus 4, and the remaining terms are s into 0 becomes 0, we are having minus 1 alone equal to 0. So if you keeping y n of s alone in the left hand side, then this becomes y n of s is equal to 1 by s square plus 5s plus 4. So we need to solve for y n of t to get the natural response. The obtained y n of s is equal to 1 by s square plus 5s plus 4, s square plus 5s plus 4. Factorizing this, we will get 1 divided by s plus 1 into s plus 4. To obtain y n of t, we have to apply partial fraction for this term. So that will be a by s plus 1 plus b by s plus 4. We have to calculate the values of a and b, and we have to replace to apply the inverse Laplace transform. So a is equal to obtain a, find the denominator of this term, which is nothing but s plus 1. So s plus 1 into y n of s and you have to replace the resultant term with s is equal to minus 1. So here s plus 1 into 1 divided by s plus 1 into s plus 4, where s is equal to minus 1. So s plus 1 will get cancelled, and if you substitute s is equal to minus 4, then 1 divided by 3. This is the value of a. Similarly, you have to find the value of b. The value of b can be calculated in the same way. So s plus 4 into y n of s, if s is equal to minus 4, if is equal to s plus 4 into 1 divided by s plus 1 into s plus 4, where s is equal to minus 4. So cancelling this term and substituting s is equal to minus 4 will result minus 1 by 3. So we know the value of yn of s. Now yn of s is equal to 1 by 3 divided by s plus 1, and the value of b is equal to minus 1 by 3 divided by s plus 4. Now apply inverse Laplace transform to get yn of t. Apply inverse Laplace transform. Assume the system is a causal system, so we are not bothering about the ROC for applying the inverse Laplace transform. So the formula is the inverse Laplace transform for 1 by s minus a, the inverse Laplace transform of 1 by s plus a equal to e power minus at u of t. Use this formula for all the terms. So this case we will get yn of t, since the inverse Laplace transform of yn of s is yn of t, that is equal to 1 by 3. If you compare this term with the formula, instead of a we are having 1, so this can be written as e power minus t u of t, and in the second term we are having minus 1 by 3 as the coefficient, and in this term instead of a we are having 4, so e power minus 4t u of t. So this is the natural response of the system. The forced response is also called as zero state response because it is the output of the system for the input alone, considering all the initial conditions are 0. Initial state conditions are 0. So for this case we need to assume the initial state conditions are 0. So y of 0 minus equal to y dash of 0 minus equal to 0. Here we will consider the input x of t. So the equation will remain same, so that is d square y of t divided by dt square. In this case, since it is the forced response, we are making this y of t as y f of t plus 5 d y f of t divided by dt plus 4 y f of t equal to dx of t divided by dt. We know that x of t equal to e power minus 2t u of t. So applying the Laplace transform for the differential equation, we will get the same equation like the previous one, s square y f of s minus s y of 0 minus y double dash of 0, y dash of 0 plus 5 s into y f of s minus y of 0 plus 4 into y f of s, which is equal to s into x of s minus x of 0. So for the next equation, we have to substitute the values of x of s as well as x of 0. We are having x of t, so taking Laplace transform of this x of t, we will get x of s. For this case, it is 1 divided by s plus 2. And to obtain x of 0, you have to substitute t is equal to 0 in the x of t function. So which is e power 0 u of 0, which is nothing but 1. So substitute all the above condition, that is y of 0 minus is equal to 0, y dash of 0 minus is also 0, x of 0 equal to 1, and x of s is equal to 1 by s plus 2. Then the equation becomes s square y f of s plus 5s y f of s plus 4 into y f of s equal to s by s plus 2 minus 1. Here these terms are 0 because the initial state conditions are 0. So here y f of s is common, so I am taking y f of s common. Then the left hand side becomes s square plus 5s plus 4, and the right side can be simplified by taking LCM of the two terms, and then it will be s minus s plus 2 whole divided by s plus 2. Then it will be minus 2 by s plus 2, because when we are multiplying with negative sign, that minus s and plus s will get cancelled, only minus 2 will be available in the numerator. So the objective is to find the force response yf of t. So for that we are making the equation with the left hand side containing yf of s alone. So this is equal to minus 2 by s square plus 5s plus 4 into s plus 2. I just moved the polynomial s square plus 5s plus 4 to the right hand side. So yf of s is equal to minus 2 by s plus 2 into s plus 1 into s plus 4. Here we factorize the one of the denominator polynomial. So applying partial fraction to this, we can write it as a by s plus 1 plus b by s plus 2 plus c by s plus 4. We have to calculate the values of a, b and c as like the previous one. So I just use the same formula. I already calculated the values of a, b and c. I am just directly applying the values and solving this equation to reduce the time. So the value of a for this case is nothing but minus 2 by 3, and the value of b here is 1, and the value of c equal to minus 1 by 3. Now the yf of s can be rewritten as minus 2 by 3 divided by s plus 1 plus 1 by s plus 2 minus 1 by 3 by s plus 4. So applying inverse Laplace transform or taking inverse Laplace transform, we will get yf of t, that is nothing but the forced response of the system. Yf of t equal to, here this resembles this formula, inverse Laplace transform of 1 by s plus a equal to e power minus at u of t. We are assuming this is a causal system. In most of the cases they will mention a causal system is described with the differential equation like that. So for this it is minus 2 by 3 e power minus t u of t plus 1 into e power minus 2t u of t minus 1 by 3. Here instead of a we are having 4, so it is e power minus 4t u of t. As we discussed, the total response y of t is the sum of the natural response and the forced response of the system. So I have listed the calculated natural response and the forced response, and we are going to simplify the sum, that is nothing but the total response of the system. So which is equal to, first we will consider the e power minus t u of t term coefficient. Here it is 1 by 3 and here it is minus 2 by 3. If we add it together, then we will get minus 1 by 3 as result. So the sum of these two terms can be minimized as minus 1 by 3 e power minus t u of t. Then we are checking for the e power minus 2t term. In forced response available, in natural response not available, so we are just taking that term as it is. So it is e power minus 2t u of t. And considering the third term e power minus 4t u of t, its coefficient is minus 1 by 3 here. Here also it is minus 1 by 3. So adding it together will result minus 2 by 3. So minus 2 by 3 e power minus 4t u of t. So the total response of the system is nothing but y of t equal to, here I am taking u of t common since all the three terms having u of t. So your total response y of t can be written as 1 minus 1 by 3 e power minus t plus e power minus 2t minus 2 by 3 e power minus 4t into u of t. So this is how we have to solve for total response. Sometimes they will not mention the term total, they will ask you to find the response of the system for the given input x of t equal to e power minus 2t u of t or x of t equal to e power minus t u of t, like that. The same thing you have to follow. Thank you all.